This video is going to cover all of the calculator problems in the exam review packet. So we're going to start with number 34. So to use the calculator, in y equals, I'm going to hit the y equals button, I'm going to type the equation the problem provides. And then I'm going to graph it. Now the graph, it gives me a 10 by 10 window in every direction. But the problem says only look between 0 and 3. So I see here's 0, 1, 2, 3. And I want to know the maximum height, and that's up here off my screen. So I'm going to change my window. I'm going to look from -1 only to 4, since it says 0 to 3. And then for maximum height, I'm just going to change this to 20 and see if now I'm able to see the top of the graph. And I can't, so I'm going to go to my window and I'm going to make the Y max higher again. And this time, I'll try 100. Okay, so now I can clearly see the maximum. And it's asking for what height gives me the max volume. So the height is the x value of the maximum. So I'm going to go to second, calculate, which is the trace button. It's a maximum, choice 4. My cursor needs to be on the left. I hit enter. And I'm going to, oh, I messed up. Because I hit the buttons too fast, I didn't go to the right. So I'm going to start again. Maximum, left bound, enter. Now I have to go to the right bound. I'm going to hit the right arrow until we're to the right of the maximum. And hit enter. And then it asks for a guess, so I'm just going to go back in the middle. And the height we get to 3 decimal places is 1.214. And the unit is, oh, they don't tell us if it's feet or inches, so 1.214. Okay, so now for number 50, we have 3 parts to this problem. I'm going to do the same thing. I'm going to put that equation in y equals. And then it asks about after how many seconds will it hit the ground, 1.5 seconds, and maximum height. So I'm going to reset my window to a normal standard window. So I'm going to hit zoom 6. And it hits the ground right here. So I'm going to do second, calculate, that's the 0. My cursor is over here at 0.32, so that's the left. Now I have to go to the right of that x-intercept. Okay, I'm definitely to the right because my y value got negative. Hit enter. Go back towards the 0. And it calculates the x-intercept at 4. So with a grid in, you can either put 4 in the furthest right column or the furthest left column. But I'll do that for 50b. So now it says, how high will it be at 1.5 seconds? So I'm going to hit trace and type 1.5, because that's the x value we need it at. And the height is 80. So I could grid 80, lining that up on the left as well. You can either put your answer all the way to the right or all the way to the left, but not just in the middle. And then last for C, we have a maximum height, but I can't see my maximum. So I'm going to change the Y max. Just make it 100. Hopefully that's high enough. Oh, I typed 1,000. If I hit on, it stops it from graphing, so I can go back to the window and fix the extra 0. Okay, so now I can see my maximum. I'm going to hit second, trace. Choice 4 is maximum, left bound. right bound and take a guess. And it tells me that the max y value is not there, so I have to try it again. Oh, 81. I'll grid in 81. Okay, so the next calculator problem is number 65. Sketch a graph, find all the zeros. I actually could do this without a calculator because it factors. If you factor this by grouping, but I'll follow the directions. We'll use a calculator. I think it'll be a lot faster if you factored it. So if you're short for time on the final, and you notice that it factors, you can factor it. Oh, unfortunately though, we said sketch a graph, so I guess I would have to look at the graph anyway. I'm going to get a normal window. Okay, so there's our graph. The x-intercepts are -1, -3, and +1. I can see that they go through the x-axis at an integer. I also can see if I factored this, I would have x plus or minus 1 and -3 as my answers. So for the left end behavior, as x goes to -infinity, our graph f of x goes to -infinity. And for right end behavior, as x goes to infinity, the y values go to infinity. Okay, so the next problem is part calculator, part non-calculator. Problem 69. Now part A, for how many zeros does the function have? I can look at the highest degree, and there is going to be 4 of them. For real zeros, notice we can use a calculator for this problem. I'm going to look and see how many x-intercepts can I see. So I'm going to graph it. Clear that one out. And when we look at this graph, we can see 2 x-intercepts. So the function has 2 real zeros. Okay, so for 70, it's very similar. The highest exponent, the degree is 5. So there are 5 total zeros. When we graph it, we can see how many are real. And I see 1. Okay, so for 71, we're going to use the calculator to make a sketch of this inequality. Because what this is saying is, for what y values are you positive? Or is the graph positive? So if we look at the graph, I know my end behaviors are both going to be up based on it being an even degree and positive. So even though I can't see where the maximum and minimums are, I know my graph is going to look like this. So knowing about the end behaviors allows me to not mess with the window so that I can then just focus on these x-intercepts. So this one's at -1, this one's at -4, this one's at 3, and this one's at 7. So the problem is saying for where is the graph above the y-axis? That's here, here, and here. So for what x values does that happen? It's every x less than or equal to -4, every x between 3 and negative 1, and every x greater than or equal to 7. I include or equals in all of these answers because the problem included or equals in the given problem. Okay, so for 73, it gives us the solution. So for part A, I can write it in factored form. I don't even need the calculator to find the x-intercepts. I know this is all the zeros because there's 3 of them. So then for B, if I plot my x-intercepts, I don't even need a calculator for this problem. Oh, it's a no calculator problem. So I should be doing this in the calculator videos. I'll finish it here, but I'll also redo it in the other videos with the non-calculator problems. Because it's an odd power with a positive leading coefficient, my n behaviors are going like this. So the graph is going to go up, back down, and back up. So where is this less than 0 is here and here. So that's every x less than or equal to negative 6, and every x between 8 and negative 1. Okay, so 74, that's the same no calculator question. I'm not going to do that one. But 75, we can use a calculator for. So before I plug that in the calculator, I know what the x-intercepts are because I have the factors. So 0 is going to be an x-intercept, positive 6, and negative 2. And what I can do is use the calculator to get the n behaviors so I know which way this graph goes. I could also multiply in my head if I wanted to think about the degree of this polynomial. There's 3 factors, so that means the degree would be 3. And all of the x's are positive, meaning the leading coefficient is going to be positive. So the graph is going to have the same n behavior as an odd degree positive leading coefficient. And that's what we see here. We want all the places it's greater than 0, but not equal this time. So when we write the answer, it's x between 0 and negative 2, but not equal to those, and every x greater than 6. Okay, so for 76, we have to use the graphing calculator to get all of these answers. For local maxes and minimums, these answers are only y values, and intervals of increasing and decreasing, these are x values. I find these problems easiest if you draw on a picture of your graph. So once I graph it here in the calculator, I'm going to make a sketch so that I can write on it. And fortunately, since I'm on the computer, I actually can take a picture of it. You will have to draw it for your test or your final. And now what we're going to do is label the maximum and minimums, because the values at the max and the min are going to get me the answers to all 4 of these boxes. So we're going to do second, calculate, maximum. It doesn't matter which one you start with. I like to go left to right. So I'm doing left bound, and then I have to go to the right of the maximum, hit enter, go back towards the maximum, hit enter, a third time. And now we have to use our math knowledge to know that this point is at -5, 8.3 repeating, which I can change to a fraction if I'd like, or I can leave it as a decimal. And then now this point, I'm going to calculate the minimum. That was another choice in the calculate menu. Oops, sorry, I have to go to the right. I need to be to the left of this minimum. Enter. Go to the right-hand side, hit enter. Back towards the min. And this value's at, and again, we're going to round this. It's -1 and then -2.3 repeating. Your calculator is only approximating the maximum and minimum coordinates. So you have to use your math knowledge to round that appropriately. So our max value is 8.3 repeating. Our minimum value is -2.3 repeating. And then this cutoff is -5, and this cutoff is at -1. I only care about those x values. This part of the graph is increasing. Remember, we always go left to right, decreasing, and then increasing. So the part in the middle is decreasing. So for the increasing intervals, that is every x less than -5 and every x greater than -1. The graph is decreasing for every x between -1 and -5. Okay, so we're going to repeat that whole process for g of x. And I'm not sure the calculator is going to know that that means 2x to the third versus just x to the third divided by 3. So I'm going to insert parentheses around this numerator just to be absolutely certain that the calculator knows I want the entire 2x to the third divided by 3. I'm going to do the same thing for the next fraction. Okay, so let me So here's our graph for g of x. We're going to mark that up with our calculator. So I need all the maximum and minimums. So let's start with the minimum that's on the far left. Oh, I went too far. I'm going to go to the right of the minimum. Take a guess. And it tells us this point is at -2, -0.86 repeating. I'm going to do the same thing for the maximum. We're to the left there. Now I have to go to the right. Hit enter and go back towards that max value. And this point is at, again, we have to round this, so that's 1 and 7.083 repeating. So that's actually going to be our maximum value. And then lastly, for the minimum, my cursor is to the left, so I'm going to hit enter. Then I have to go to the right. Enter, go back and take a guess. And this point is at 3, 1.75. Now because it asked for the values of the local minimums, both of these mins are local minimums. So that's -8.6 repeating and 1.75. So now we have to do our answers for increasing and decreasing. -2 is a cutoff, 1 is a cutoff, and 3. So if I want to color code this, this is decreasing, increasing, decreasing. And then it's always left to right, decreasing, increasing, increasing. Okay, so for the increasing values, that happens for every x between -2 and 1. And again, for every x greater than 3. And then the decreasing values, that's for every x between 1 and 3, and every x less than -2. Okay, so for 77, going to first have to find out what type of polynomial fits this data. So I have to do the regression. I have to subtract these values to see when I get a constant. So 434 minus 400 is 34. 436 minus 34. So those are not constant yet, so I'm going to subtract again. So 2 minus 34 is -32. -30 minus 2 is -32. So this is quadratic because it happened on our second level of subtracting of the finite differences. So I'm going to hit the stat button, hit edit, and I have to type in the x and y values to L1 and L2. Now I'm going to quit to the main screen, hit stat again, and arrow over to calculate. And we decided it was quadratic, so that's choice 5. Hit enter. If you have newer software in your calculator, you have to arrow down to calculate to get the equation. And I'm going to fill in the A, B, and C values. So how high is it after 4 seconds, and when does it hit the ground? So I'm going to graph this equation. So when I hit, I'm sorry, not second. I just want to hit trace 4 for 4 seconds, and that gives us 344 feet for a height. And when it hits the ground, I'm going to calculate the 0. My cursor's to the left. I have to go to the right. I want to look to see when this y turns negative. I'll know it'll be to the right. I'll take a guess. And the time is 6.801 seconds. Okay, so now for these last few problems, for 78 and 79, determine the degree. We don't need a calculator for that because they're saying we can do the finite differences and subtract. So if we subtract 14 by 5, we get 9. Subtract here, we're going to get 23. Subtract again. Now, for our purposes, if you're doing your exam review packet and you want to use your calculator for the arithmetic, that's fine. Just know that on your final, what they're telling you is technically this question could be on a non-calculator multiple choice question, and you would have to do this subtraction by hand. Let me get myself some space here. So then we have to subtract again and see if we get a constant. 69 and 43, it's 26. And then subtract again, we're going to get 6 and 6. So this one is cubic. It's a degree of 3. So I'm going to go to the stat, edit, I need to clear out my prior list. So I'm going to go up to L1 and hit clear, enter. Do not hit delete. It will actually delete the whole column. You have to hit clear, enter. I'm going to type in these values. Type in the y values. Quit, stat, calculate. And this time we said it was cubic, so that's choice 6. So that's 1x to the third plus 1x squared minus x plus 4. Okay, we're going to repeat the same process for b. Or clear. So I have to subtract. Subtract again. They're all 2's. Because it was the second subtraction, it's quadratic. We have to type in all our values. I'm going to clear these lists. Uh-oh. You have to make sure you type everything correctly. If you have one digit wrong, one decimal wrong, your calculator will not give you the correct answer because it's fitting the equation to the data. It's like in Algebra 1 when you did line of best fit. Now instead of lines, we have quadratics or cubics of best fit. So this one, y equals x squared plus 2x plus 3. Okay, and now last but not least, 80 and 81. These say they could be calculator problems. When we did them in class, we didn't use a calculator, but it can't hurt, especially for the arithmetic. So let's see, for 80, they give us the vertex, and very nicely, they give us the vertex form of the equation. So the vertex is h and k, and the point that passes through in x and y. So our job is to solve for a, the leading coefficient. Minus -3 is plus 3. So now calculating this is 10 squared. So solving for a, we're going to add 2. 10 squared is 100, divided by 100. And we get 0.4 is a. So your final answer, we have to go back up. We're going to fill in a, h, and k. So that's y equals 0.4 x plus 3 squared minus 2 as our final answer. So this could be a calculator problem if you wanted to do any of the arithmetic in the calculator. And lastly, for 81, we're going to do the same exact thing. 52 equals a, x minus 1 squared plus 4, but I should put that x value in. It's 5. We're going to subtract 4. This is 4 squared, so that's 16. So when you divide 16 to the other side, we get a is 3. So our answer is y equals 3, x minus 1 squared plus 4.